Hi students, good morning. Today we are going to start our new chapter, and that chapter name is Newton's Laws of Motion. So I know you are already knowing the Newton's Laws of Motion, and it's just an revision. Means you have already learned these concepts in your lower classes. So we are revising it, and some extent we are defining some new terms here. That only we are going to do in this chapter. It's a very simple chapter, very interesting chapter, and you can find the concepts that we are discussing here in your daily life situations. That is an advantage, or that is one speciality of this chapter. That means all the content or all the concepts that we are defining or describing here, that you can easily understand from your daily life situations. As far as I concerned, the greatest scientist that we have ever seen is our Isaac Newton. As I already told you, he was not a physicist initially. He was a mathematician, and after that he found more beauty in physics. Then he changed his focus from mathematics to physics, and he has made the first authentic statement regarding almost all branches of physics. Whenever you study the history of physics, you can find that the first statement made by Newton regarding almost all branches of science prevailing on those days. And some of them are discarded, and some of them are modified, and some of them are still keeping as such. That is the greatness of Isaac Newton, and we have to consider his lifetime also. That means he is in 1842. He was born in 1842, and I mean at that time science was not developed too much, and the equipments are very less. And with his minimum input, he has given his output as much as he can. That is his greatness, and that's why I admire him more as a greatest scientist in the realm of physics. Anyhow, that is not our matter. Our matter is the laws of motion, and Newton formulated three simple statements, and that three simple statements guides the movements in the whole universe. That is why these three statements are called universal laws of motion, Newton's laws of motion. And these three laws are familiar to you. The concepts behind these laws are also familiar to you. We have to revise those laws or statements now. For that, we can start with the first law of motion. The first law of motion. The first law of motion states what it says. It states that every object will continue in its state of rest or uniform motion along a straight line until it is compelled to change its state by an external unbalanced force. That is the first law, and this is a statement for the first law of Newton's first law of motion. And all the terms he used in this statement is very important. All the terms used are very important, and we can carefully analyze the statement given, not its meaning, only the statement. Every object, every object will continue in its state of rest or state of uniform motion along a straight line, until it is compelled to change its state by an external unbalanced force. External unbalanced force. So suppose a system is in its state of rest, so it has no velocity. It is under rest. It will continue in its own rest. Suppose a particle is moving and its motion is a uniform motion along a straight line. Uniform motion means its velocity will not varying, and along a straight line, it means velocity is a vector quantity, so its magnitude already we have restricted, it should be constant, and it travel in a straight line, so the direction also should be same. So there is no change in velocity in its magnitude as well as in direction. Strictly when velocity is restricted. So if a body is under rest, no change at all for this state of rest, and if it is moving, its velocity will not vary in magnitude and direction. That means it is strictly restricted. When until it is compelled to change that state. That object can change its state only by an force. Only by a force. What kind of force should be that? That force should be, adjective used are, force should be unbalanced and external force. So if you are having an external unbalanced force, with that external unbalanced force only, you can change the state of a system. That is the outcome of that statement. If you want to change the state of a system, if you want to make the changes in its velocity, what to do? You have to apply an external unbalanced force. For an internal force, you can't change the state of a body. For a balanced force, you can change this. What do you mean by a balanced force? Two forces acting in equal magnitude and opposite direction in terms of vectors. Two equal magnitude force acting in just opposite directions. That is a balanced force. So balanced force cannot change the state of a system, and an internal force also cannot. What do you mean by internal force? Suppose you are sitting in a car and you are trying to move it by pushing it from inside. Is it possible? No. Suppose you are standing outside and you are applying the force, and sometimes with the same force you can at least move it. Is it? What is the difference there? The same force you are applying sitting inside the car, in the first situation you are failing. And if you are applying the same force standing outside, you can win over that. So external force is only possible for change the state of a system. And suppose a table is there and two persons with equal force are pulling it from opposite sides. Will it move? No. And if anyone is applying more force than the other, then it will move in that particular direction, which means unbalanced force is necessary for a state change. So to change the state of a system, how you can identify a state change? I will say you can sense the state change by identifying a velocity change. Velocity change means sometimes it may from 0 to a positive value, or 0 to a, or positive value to a non-zero value to a zero value, or a decrease in its velocity or increase in its velocity, or either in the change in its direction, velocity direction. Are you getting me? So simply you can identify the state change, state of rest to state of motion, or state of motion to state of rest, whatever may be. You can identify that state change by sensing a velocity change. So simply the first law says that without any force, external unbalanced force, there is no velocity change, which means there is no state change. That is the crux of that first law. That is the crux of first law. Without any unbalanced external force, there is no state change. Without any external unbalanced force, there is no state change. And why there is no such a state change when there is no external and balanced force? Because every system has a tendency to continue in its own state in which that is now. Suppose a state system is at rest, it will continue, it has a tendency to continue in the state of rest. Suppose a particle is moving, if there is no such any opposite force, it will continue in its state of motion. Are you getting me? It will not change its velocity even. So every system has a tendency to continue in its state of rest or uniform motion like a straight line. And that natural tendency of a system to continue in its own state, that is known as inertia. That is known as inertia. So what do you mean by inertia? Inertia is the natural tendency of a system to continue in its own state. Natural tendency of a system to continue in its own state. So what are the measures of this inertia? Suppose you are having a small stone or a small yes, a stable or a small stone is there, and if you are applying a force to move it, can you move it? Yes. But instead of that small stone, you are having a massive, heavy, big rock. Can you move it with the same force? No. Why? Because it is massive. So, how you can move that small stone by a force if that applied force is sufficiently enough to overcome its inertia? Are you getting me? If you are applying a force, listen me carefully, if you are applying a force and that force is necessarily enough to or sufficiently enough to overcome the inertia of that system, then only you can change the state of that system. Suppose your friend is riding a bicycle, you want to stop him, you called him and you are not, he is not listening and he is moving, so you are holding that bicycle and hold it tight. Sometimes you can stop him, is it? With the same force, can you stop a bike, or can you stop a running bike or running car? No. Why? Or the same person is moving with a high velocity, or a heavy person is riding that bicycle, with the same force, can you stop them? No. So there are many factors that can decide the um, inertia of a system. So we can say that there are three types of inertia. There are three types of inertia, and these three types are inertia of rest, inertia of motion, and inertia of direction. Inertia of rest, inertia of motion, and inertia of direction. And you have experienced all these three effect of inertia or factors of inertia in your daily life. Inertia of rest means, suppose a system is in rest, it has a natural tendency to continue in that state only. That is inertia of rest. What is inertia of motion? If a particle is in a movement, uniform motion, there is no change in its velocity, it has a tendency to continue with that same velocity. That is inertia of motion. Suppose a particle is moving the same direction, in a direction, it will not change that direction even it is, until it is acted upon by an external unbalanced force. It will continue the same direction. Again, that is inertia of direction. So these three are the types of inertia: inertia of motion, inertia of rest, and inertia of direction. And we have defined inertia as the natural tendency of the objects to continue in its state of rest or uniform motion along a straight line. The natural tendency of a system to continue in its own state of rest or uniform motion along a straight line. That is inertia. So, since this term inertia is derived from the first law of Newton is also known as inertia, law of inertia. It is also known as law of inertia. Okay. Okay, we have started with the laws of motion, and we can see the statement for the first law of motion. Newton's first law: every object will continue in its state of rest or uniform motion along a straight line until it compelled to change its state by an external unbalanced force. So, the force which is trying to change the state of the system should be external, it should be unbalanced force. And the tendency of a system to continue in its own state is known as inertia. The natural tendency of a system to continue in its own state, that is inertia. There are three types of inertia. Which are these three types of inertia? We have already discussed. It's inertia of rest, inertia of motion, and inertia of direction. I already told you have experienced all these three types of inertia from your daily life. First one we can take in an example, inertia of rest. So, inertia of rest means you can't change. Suppose you are in rest, you can't change its a system. Suppose a system is in a state of rest, and you can't change, or it can't change its state by its own efforts. It can't change its state by its own efforts. Suppose when a bus starts suddenly, the passengers standing inside leans backwards. Suppose you are standing in a bus, and the bus is state of rest, and you are not holding anywhere. Suddenly, the driver starts the bus and starts to move. What will happen to you? You will lean backwards. Why? That is due to the state of inertia of rest. Suppose you are standing in the bus under rest. So the platform of the bus the person standing on that platform, both are in the state of rest. No velocity is there. And when the bus suddenly starts to move, the platform of the bus starts to move. Since you are standing, your lower part of the body attains the velocity of the platform and it starts to move. But lower part of your body attains the velocity of the platform and starts to move. But your upper part of the body still try to continue in the state of rest. Obviously, that part will try to stay back there, but the lower part will move. What will happen? You will lean back. Is it? So, that is the example for inertia of rest. Again, when we are cleaning our home, and when a carpet is when we are cleaning a carpet, what we are doing, we are keeping the carpet and beat with a stick. Then the dust particles, we can see that the dust particles are coming out. Why? That is again the example for the inertia of rest. When it is beaten, carpet comes in motion, but the dust particle remain at rest. So they will come out. Then when a card carrying a coin and placed on a bottle is flipped away quickly with the finger, the coin falls in the bottle. Or suppose you are, another example I can show you. when you are playing caroms, all the coins are stacked one over another, and with the striker you are suddenly strike with the bottom one, all others will be back without any movement. Did you ever seen that? We are hitting the bottom coin only, and it will move away with the velocity, and all others will get back to the board without any change, without any shake. That is again another example for inertia of rust. So when we shake a branch of mango tree, the mangoes fall down. Then a bullet fired against a window glass makes a clear hole in the glass window, cracking it without cracking it. And all these are examples of inertia of rest. Then we can go for inertia of motion. And we have already said that when you are in a bus at rest, and when suddenly it starts to move, you will fail back. And suppose you are in a running bus, platform is under motion, being inside the bus you are also in the with the same velocity. Suddenly the driver brake applies. What will happen? Suddenly the platform comes to rest, lower part of the body comes to rest, but your upper part of the body still wants to move in the same velocity due to the inertia. So what will happen? The upper part will move up, move forward, and the lower part will suddenly comes to rest, so you will fell forward. Okay, so that is another example for, that is an example for inertia of motion. Again, a person getting down from a speeding bus falls in the direction of motion of the bus. Again, that is an example for that is due to the inertia of motion. An athlete runs some distance before taking a long jump. Why? Because he has to attain maximum velocity, and with that pace he can jump a more distance. And when a passenger sitting in the train moving with a uniform velocity throws a ball vertically upwards, the ball returns back to his hand only. That is again the example for inertia of motion. Then, inertia of direction. Mud flying tangentially to the surface of the tire of a car. That is a example for inertia of direction. And suppose a an elephant is chasing you. Imagine that condition. An elephant is chasing you. You have to escape from that elephant. What you have to do? You have to. You have advised to move in random direction, zigzag direction. Why it is so? Elephant is a massive one, and being lighter, you can easily change your direction. But due to inertia, if elephant is moving in one direction, it can't change its direction easily. So you can keep a larger distance from the elephant if you are moving in the zigzag direction. Okay, so that is also an example for direction. Okay. So we have seen there are two factors on which that inertia can depend, or the inertia can be decided by two factors. One is mass and the other is velocity. If the velocity is more, its inertia will be more. Its mass is more, its inertia will be more. So the factors affecting inertia can be clubbed together. Factors affecting inertia can be clubbed together. And that unified quantity is measured as the product of mass and velocity. Why we are keeping that mass and velocity together? I already told you these are the two factors which decide the inertia of a system. If its mass is more, suppose two objects are having the same velocity, if the mass is more, inertia will be different. Two objects are there with the same velocity, one is massive and the another is lighter. To stop both, are you applying the same force? No. Massive one needs more force. Why? Its inertia is more. I already told you, if your applied force is sufficiently enough to overcome its inertia, then only you can change the state. If both the particles are at rest, one is massive, another is lighter, which can be easily moved? Lighter one, because its mass is less. So to change the state of the system, you need a force, external unbalanced force. How much force you have to apply? That is determined by inertia. And that inertia is determined by these two factors, mass and velocity. Listen carefully. If you want to change the state of a system, you have to apply external unbalanced force. I am not using that external unbalanced. It is obvious that whenever I am talking about the force, that should be external and unbalanced. Okay, so if you want to apply the state of a system, you have to apply force, and that force should be sufficiently to overcome the inertia, and inertia is determined by either its mass or its velocity, depending upon the situation. So we can club these two as the product mass into velocity. But it doesn't mean that if a particle is having mass, it is not having velocity, it will not possess inertia. That is another condition. Anyhow, the factors affecting the inertia, that is mass and velocity, we are clubbed together so as to define another physical quantity called, yes, I can hear that some of you are saying that it is momentum. So momentum is, I define momentum as the impact generated by a system on other systems, the impact made by an object on others, and it is measured as a product of mass and velocity. That is, capital letter P is momentum, and it is measured as a P is equal to m into v, where m is the mass and v is the velocity. I just told you I can define, or I defines momentum as the impact generated by a system on others. Why I define like that? Suppose you are having a heavy stone and a lighter stone. Both are from the same height, both are just dropping to your leg. A heavy stone you are dropping to the leg, you feel hurt. A lighter one you are dropping to the same height, to the same velocity to your leg. In which situation you will feel more hurt? Heavy one. Both are having the same velocity, and what is the difference there? Mass. If the mass is more, the impact made by the stone to your leg is more. Is it? Yes, it is. Suppose you are having a stone, and you are asked your brother or sister to just throw it to your back slowly, and the same stone he is again, you are again handing over to him or her, and he is throwing with a pace to your body. Same stone, but the velocity is different. What will happen? Can you bear it? Obviously you will beat her or him. So what made the changes here? Even though the mass is same, the velocity is different, it can make a greater impact. That is why I told you momentum is the product of mass and velocity, which can be defined as the impact made by a system on others, and it can be measured as the product of mass and velocity. If the mass is more, its impact is more. Velocity is more, impact is more. If both are more, then straight it can make a greater impact on other bodies. Okay, so that's all for today, and we have started with our new chapter. We have seen the first law. From the first law, two terms we have defined: inertia and momentum. Okay, we will meet in the next class.